Okay, so for this number 8, they tell us that the area is 13 halves. And they tell us that it's a right triangle, so we're gonna go with 1/2 base times height. And then they tell us the base and the height, so let's fill those things in. Okay, so this is the general setup. I have the given area. 1/2 is just part of the formula from like middle school, 1/2 base times height. So 1/2 is just 1/2. They told us that this is the base, right? This is the base of the triangle. And they told us that this is the height. So this is the setup. And right away, I'm gonna get rid of the 1/2. So I'm gonna multiply this side by 2. And I'm gonna multiply this side by 2. So this 1/2 is knocked out with 2. And this just gives us 13 right here. And then we have these two pieces there. So what we can do is maybe we can look at these 4 sections and try to factorize them. For instance, here this stays the same, and here that's a difference of squares. X minus 3 times x plus 3. Now, if you do the Desmos technique where you graph this on Desmos to see where it crosses the x-axis to find the roots and to then build factors, you would see that this here is the factorization for this numerator. It should be that, like that right there. And now we look all across this paper and we see that this knocks out with this and this knocks out with that. So we would be left with 13 is equal to 2x plus 5 over x take away 3. And then what I would probably do is I would multiply both sides by x minus 3. Because then here these knock out. And on this side we can distribute to get 13x take away 39 equals 2x plus 5. I'm going to move the 2x and I'm going to move the 39. Subtracting 2x from 13 gives you 11. Adding 39 with 5 gives you, was it 44? So we get that x is 4. But we also know that this here was the base, and we know that this here was the height. So what I want to do is I want to find the base and height specifically. So I'm going to take 4 for x, and I'm going to plug it in there to find the base. And I'm going to plug it in there to find the height. And on my Casio, I did just that. I plugged in 4 for x all there to find the base, which is that. I plugged in 4 for x there to get the height, which is that. And so now I know that this triangle, this right triangle, has a base of 39 over 7 and a height of 7/3. But I think in the word problem, they mentioned something about the perimeter. So you're going to have to find the hypotenuse by going Pythagorean Theorem. And doing the Pythagorean Theorem, if you square add these together, then square root to get C alone, you're going to find that the perimeter, or that the hypotenuse, it's about 6.04. And so why don't we actually find the perimeter of this triangle by adding together these 3 sides and rounding to the nearest hundredth. And so we have that the perimeter of the right triangle, it's about 13.94 feet. But the goal had to do something with money, and it said something like it costs $2 for every inch. The key word is inch. So what you're gonna have to do is turn this feet into inches. So let's take 13.94 and let's multiply that by 12, and we get about 167.28 inches. So that was probably the sneaky part where you actually have to convert from feet to inches. So the perimeter has this many inches. And they said that I think they said it's $2 for every inch. So let's take that 167.28, and if you times it by 2, then in terms of the money, we're talking about $335 to wrap up this triangle, the perimeter, to wrap it up in fencing. That's $2 per inch, about $335.